In the last video, we show how to use traditional method and p-value method to test this claim for this right tail test. Now I would like to continue from there. Suppose this time I just on purpose change this to two-tail test and want to show you how to do how you change what do you do to use traditional method and p-value method to test this two-tail test claim, two-tail claim. So now to use traditional method, if you can recall that we really have to just I'm gonna draw a bell shape, use the alpha 0.05, and the alpha should be split it into half, so that each side is half of it, which is 0.025. Okay, and this is the critical region, this is also critical region, and we need to find those two values. And if you can recall, you can verify that from the StatsCrunch. If this is 0.025, this is gonna be negative 1.96, and this is perfectly symmetrical, so this will be 1.96. So please check that by yourself, and I'm confident that you at this point in time you should be able to find given area, find the value in StatsCrunch. Now time to see how to make the conclusion, because Z is 3.21. Again, 3.21 is way out here, right? 3.21, and this is critical region, which means rejection region. Therefore, we should reject HO and conclude that H1 is supported. So this is how to use traditional method. As far as the p-value method, and now this time we have two-tail test. So I'm gonna draw a graph. Here, what I should mark is the test statistic 3.21. So 3.21 is on the right hand side, 3.21. And because it's on the right side, I should find this tail area, use StatsCrunch. And it can be shown that this is 0.00066, so I'm going to run to 4 decimals, which is 0.007. Therefore, the p-value, because it's two-tail test, it will be twice of this, double it, 0.007, which is 0.0014. And certainly it is less than alpha, 0.05. Therefore, we are going to reject HO. The P is low, the no must go. So reject HO. You can see that both reach to the same conclusion. Alright, the last decision-making method is use confidence interval. If you can recall what confidence interval means, so confidence interval is an interval that you're pretty confident that the population parameter will be somewhere here in the interval, right? So therefore, if the HO, the parameter hypothesized value in HO falls inside that means it is something you are confident about. In that case, you don't reject HO. If the value falls outside, either here or here, then you're gonna say you reject HO. So now I'm gonna let's take a look at the first one. Suppose you're gonna test this right tail test. So at this level, and what confidence interval you should find? 1 minus twice of the alpha, because this is one tail test. Confidence interval is actually for two tail, so we have to double the alpha. So which means 1 minus 0.05 times 2, which is 90% confidence interval. Okay, so you need to find 90% confidence interval. Suppose 90% confidence interval is given. Let's see, 227 is falling outside. So therefore you're not because it's not in the confidence level you're confident about, right? Therefore, your conclusion is you reject HO. Reject HO. Okay. Now suppose the confidence level is 200 to 230. In this case, this guy is in between the numbers you are confident about. Therefore, you're gonna say, hey, I have no reason to reject HO because this is one of the number I'm confident about. Okay, so therefore you fail to reject HO in this case. So it's fairly easy when you use confidence interval method. Just look at whether it's inside or outside. Now, this time this is a two-tailed test. Alpha is 0.05. Here you just want minus alpha when you find confidence interval. Don't double the alpha because this is already two-tailed. It matches confidence interval. Again, if this value is inside the confidence interval, then you fail to reject HO. Now, the second example here, it's outside, so you're gonna reject HO. So that's it. That's it for the confidence level method.